Welcome to the third video in the JavaScript Functions series on promises and async await. This video is for those who are tired of wrestling with complex asynchronous code and wish to write easy to understand and maintainable code. I will show you how promise chaining and async await can simplify your coding life. For this, we will cover the topic of promise chaining and start with the sequential chaining, which occurs when multiple operations are chained together in a sequence. Then we will learn about parallel chaining using Promise.all method, which resolves when all promises resolve or rejects if any promise rejects. The short circuit chaining, which uses Promise.race method, which resolves or rejects with the result of the first settled promise. Now, Promise.allSettled method, it patiently waits and resolves when all the promises settle, whether they are resolved or rejected. And Promise.any, that resolves with the first fulfilled promise. It rejects if all the promises reject. In addition to this, we will also understand the concept of async await, where we will learn the purpose of these two keywords. We will implement the code using async await, understand how we do error handling with async await, and finally we will learn about the chaining promises with async await. Let's get started. In the last video, we learned about sequential chaining when we passed promise objects to multiple .then or .catch methods. In this video, I will formally introduce sequential promise chaining. When multiple asynchronous tasks execute one after the other in a specific order, each task starts once the previous task resolves. This allows to control the sequence of operations, and any error during the execution is centrally managed using the .catch method. I wrote a few functions to illustrate promise chaining with the help of an example, and I have written normal functions to keep this explanation simple. The first function, getInitialNumber, is an executive function that calls the resolve method with a value of 3. This is followed by a few functions that calculate the number they receive as a parameter, such as squaring, adding, and multiplication. Now I create a promise object and pass the getInitialNumber function as an executor to the promise constructor. And once I get the promise object, each .then method does one of the calculation. And after the calculation, it passes the updated value to the next consumer in the promise chain until the final result is shown. Remember, since the functions are synchronous, a simple return statement causes a promise object to resolve with the return value. And here is the graphical representation of this code. Now we will see how Promise.all works. The Promise.all is a static method that handles multiple concurrent asynchronous operations, which are passed as an iterable to this function. When all the asynchronous operations are fulfilled or resolved, this function creates a new promise object and calls the resolve function. And the new promise object returns an array that contains the result of these asynchronous operations. When one of the asynchronous operation is unfulfilled, then this function returns a new promise as rejected, and it returns the result of the failed asynchronous operation. In this figure, when all three asynchronous operations resolve, the promise chain executes the .then method, which receives an array of resolved data. And when one of the asynchronous operation rejects, the promise chain executes .catch method with the result of the failed promise. Let's examine this with the help of an example, and for this too, I wrote 3 functions. These are the first, second, and third function. All 3 functions return a new promise object with the resolve function call and pass back the value. Now I put all the 3 functions in an array and pass this array to the function called Promise.all. Note that I am executing these functions in an array. Since all the functions resolve the promise, the function Promise.all returns a new promise object with resolve that calls the .then method in the promise chain, and it returns an array of the resolved data. You can see this data when the .then method executes the fulfilled function. Now in the second code snippet, I make a change in the second function, which returns a new promise object with the reject function. Now in this case, the promise chain will give control to the .catch method, which will execute the rejected method and show the value of the rejected data. The function Promise.all is useful when we need to perform various asynchronous tasks concurrently and wait for all of these to complete successfully before proceeding. Now we will learn about Promise.race method. Just like Promise.all, the method Promise.race is also a static method that handles multiple asynchronous operations passed as an iterable to the function. When any of the asynchronous task resolves or rejects, this function returns a new promise object that fulfills or rejects with the value of the asynchronous task. Now in this figure, when an asynchronous task resolves, the function Promise.race creates a new promise object with the resolved data and passes the control to the .then method of the promise chain. And when the asynchronous task rejects, the function Promise.race creates a new promise object with the rejected data and passes the control to the catch method in the promise chain. Let's examine this with the help of an example, and I will use the same three functions. All the functions resolve in 2 seconds. I put these functions in an array and pass this array to the function Promise.race. Note I have called these functions in an array, which eventually will contain a resolved promise object for evaluation. Now, since the returned promise object has been resolved, the promise chain will give control to the .then method, which executes the fulfilled function to show the value of the resolved asynchronous operation. Now I've made a change in the first function. Now this function now rejects, and this makes the Promise.race to return a new promise object with the rejected data. And the promise chain now passes the control to the .catch method, which executes the rejected method to show the rejected data. This covers the usage of Promise.race function. We can use Promise.race method when we are trying to fetch data from multiple sources and are interested in only the fastest available source. Or we can use this to terminate any long-running operation by racing a promise against the timeout. Now we will learn about Promise.any method. Promise.any method is also a static method that handles multiple asynchronous operations passed as an iterable to the function. This function returns a new promise object with the value of the first resolved promise. When all of the asynchronous operations reject, this function returns a new promise object with the aggregate error object, which contains an array of the rejected reasons. Now in this figure, when any one of the asynchronous operation resolves, a new promise object is created with the resolved data, and the promise chain executes the .then method, which receives the resolved data. When all of the asynchronous operations reject, a new promise object is created with an array of rejected data, and the promise chain executes .catch method, which receives this array of rejected data. Let's examine this with the help of an example. I again use the same three functions, and here the first function returns a new promise object with a reject reason after a delay of 1 second. Now the remaining two functions return a new promise object with a resolve reason after a delay of 2 seconds. Now in this case, the function Promise.any returns a new promise object with resolve and passes the value of the first fulfilled promise. And this passes the control in the promise chain to .then method, which displays the value of the fulfilled promise. Now in the second instance, all the three functions return a new promise object with the reject data. Now this makes Promise.any function to return a new promise object with an array of all the rejected reasons. And this passes the control in the promise chain to .catch method, which displays the reasons for all the unfulfilled promises. This completes the coverage of Promise.any method. Now we can use this method when we want to fetch data from multiple sources and use the first successful response, or when we want to retry a request for a certain number of times and use the first successful request. Now we will learn about Promise.allSettled method. Promise.all is a static method that handles multiple asynchronous operations passed as an iterable to this function. Now this resolves a new promise object when all the promises in the iteration are settled, either resolved or rejected. The new promise object returns an array of objects, each representing the value of an asynchronous operation in an iterable. Now in this figure, when all the operations settle, either resolved or rejected, a new promise object resolves with an array that contains the result of each asynchronous operation and invokes the .then method of the promise chain. Here is an example. I'm again using the three functions. The first function rejects and the remaining two functions resolve. When all the operations settle, the new promise object resolves and passes control flow to the .then method, which displays each object's status and value. This function does not return a new promise object with a reject reason. We can use this function when we want to ensure that all the operations are complete regardless of the status before proceeding. Now this completes our topic of promise chaining. Let's summarize what we have learned so far. Now we will start with async await. Async await are two keywords which are built on top of promise, which allows you to write async code that is easy to read and looks like a synchronous code. It is actually a syntactical sugar on top of promise. So let's talk about the async keyword first. It allows you to define a function that handles asynchronous code, and you must put the keyword async before the function definition. And this indicates that the function returns a promise object. Let's have a look at the code. For this, I write a simple function test that returns a string object. And when I add the async keyword before the function keyword, this function now returns a promise that resolves with the value test string. Now we will look at the await keyword. We use the await keyword to wait for a promise to settle. In other words, it pauses the execution of the async function until the promise settles. We can use this keyword only inside an async function. If we try to use it outside the function, the JavaScript throws an error. Let's have a look at the code. I write a function called fetchData. Now this simulates the data fetching with a 2-second delay and returns a promise object. Now I write another asynchronous function, processData, that calls the function fetchData with the await keyword. Now with this await keyword in use, JavaScript waits at this point till the function fetchData completes the execution. And once it's done, the function processData resumes execution and prints the fetched data values. Now we will use this information and write a function to read data from 3 files asynchronously and display the same. So for this, I write a function read data file. Now this function reads a file using a synchronous read file function. So when the read operation completes, it passes the data back via the resolve function of a new promise object. Now I write an asynchronous function that reads 3 files one after the other. For each read operation, the function awaits the read operation to complete, and finally it prints the data. Now we will see how we can do error handling with async await. Now with async await keywords, the asynchronous code looks like a synchronous code, and we can use try catch keywords in a straightforward manner and implement error handling the way we do for other synchronous code. Let's see this with the help of an example. And for this, I write a function with the async keyword to pull data from a URL. And I use the asynchronous function fetch to fetch this data. So the function waits for the fetch to complete before it proceeds. Now I put this fetch function call under the try catch statement. And since the provided URL is incorrect, the fetch statement causes an exception and passes the control to the catch block for execution, where it shows the error message. Now we come to the last topic of using async await with promise chaining. Now in this example, to reiterate, the async function reads 3 files in a sequence, and for each read operation, the execution pauses. Once all the files are read, the data is displayed. So instead of using the .then method to chain the read operations, the async await makes the promise chain looks like a synchronous code. If we do not want to wait for each operation to complete before starting with the next one, we can use the function Promise.all with async await to execute the tasks in parallel. Here is the code for the same. And do note that not only this, but you can also use, as per your requirement, other functions like Promise.race, Promise.any, or Promise.allSettled. Now, after going through these examples and explanations and the exercises shared on GitHub, I'm quite sure writing asynchronous code in JavaScript should not be tough for you. And with this, I conclude this video. Let's summarize the concept of async await. Thank you for watching this video. If this video has helped you, please like it. If you think this can help any of your friends, do share it. And finally, do subscribe so that you don't miss any other videos in future. Thank you very much. Keep learning.